Let's look at example 2 now. Okay, example 2 is slightly different from example 1 in that, okay, there is no actual figure here, but we're just given a curve that has this equation. And if you look at this equation, you should know that it is a, yes, quadratic curve. Okay, so you're given this equation and you're told that the rate of change of x is 2 and you're supposed to find the rate of change of y. So let's translate this into what we know. Okay, rate of change of x is 2. That means that, remember now when we say rate of change, we immediately refer to, okay, we know that this refers to the rate of change of x with respect to time, and we can express this as dx over dt. And so from here we can infer that dx over dt is 2. And you are asked to find the rate of change of y, so we know that the question is asking us to find dy over dt. So earlier on, okay, looking at the formula for connected rates of change, we know that to find dy over dt, okay, we can just take dy over dx times dx over dt. Okay, so that we can, it's almost evasive, though we can cancel out the dx and we are left with dy over dt. So over here we already have dx over dt, which means that, okay, for us to actually get dy over dt, we need to first work out what is dy over dx. And to work out dy over dx is actually quite simple because we know y is equals to 3x squared minus 1. So to work out dy over dx, very simple. Okay, we'll just differentiate this. You should be able to do this quite quickly. Okay, you should get 6x and then minus 1. When you differentiate, you get 0. Okay, so putting this back inside here, we know that dy over dx is equals to 6x. dx over dt is equals to 2. So we get 6x times 2, which is 12. X. And we are asked to find specifically what is the rate of change when x is equals to 2. So we know that at x equals to 2, dy over dt will be equals to 12 times 2, which will give you 24, and the units will be units per second. Okay, so this is example 2. Basically, it's just asking you to make use of, okay, the formula for connected rates of change. So once you can recognize this, you can see that, okay, it is actually very simple to find the value for dy over dt, or the rate of change of y.